Hello and welcome to this new episode of Minds Between Languages. Our guest today is Adolfo García, who will talk about the multilingual brain. Hi and welcome to a new installment of Minds Between Language. This is actually a very special installment because it's our anniversary episode. Yay, 20th anniversary of Minds Between Languages. And because this is such a special episode, we have a special guest with us, the creator of our podcast, Minds Between Languages, Adolfo García. Welcome.
Thank you
Good to
very
have
much.
you.
Yeah, it's weird to be on this side of the interview.
But you are very special indeed. This is so fitting. It's also special today. You started as an English teacher, then became a translator, and kind of ended up in neuroscience. How did that actually happen?
Yeah, I don't really know. There was a little bit of design and a little bit of happenstance behind all this. One thing I do know is that when I took the English teaching program, when I enrolled in it, my goal was not to become an English teacher. That was the fastest way for me to reach the research scholarship programs that was available at the university. And because I always had a thing and a knack for languages, I thought this might be the fastest way for me to venture into this world of research. So that was really my stratagem there. And then I discovered linguistics, and I discovered that there were people in the world whose life revolved around studying and thinking and theorizing and writing about language. And I thought, okay, I can think of worse fates than this. And in the midst of my readings and my studies, at one point I discovered that you could study language in neurobiological terms, that you could explore links between how we say what we say, how we understand and misunderstand what other people say, how we acquire language, how we lose our linguistic faculties in connection to the human brain. And I knew nothing about the human brain. So I said, okay, I'd better get myself up to speed with this. And so the time came for me to decide what I was going to do my PhD on. And I said, why don't I combine all these things that are engaging me in a way? So I did my thesis on, it was a combination of translation studies, linguistics, and neuroscience. And that sort of built up the groundwork for everything that followed.
But your fascination for language is, of course, apparent also in the title of this podcast, The Minds Between Languages. So, what does actually happen in our mind when it works between languages?
Well, many things happen, and this list is not going to be exhaustive here. But let me mention a few things. One thing that happens is that, I mean, you're a polyglot, Anne-Catherine, so now you're using English with me. Well, your brain is not only activating whatever you want to say in English, it's also inhibiting what you could be saying in other languages. So that's something that's distinctive about the bilingual brain. It's something that you would not see in a purely monolingual brain just because there's no other language to inhibit as you're using your, in that case, primary and only language. The coexistence of two languages in the brain also give rise to other phenomena that are specific and distinct of multilinguals. One of them is mixing, a phenomenon that could be that can signal insufficient competence, or which may be a strategic resource sometimes, or stylistic device even. And it can happen at any level of linguistic of the linguistic hierarchy you can think of. So you can mix phonemes corresponding to the repertoire of both languages. You can mix morphemes. You can mix words. You can mix syntactic constructions. You can mix semantic associations and even pragmatic implicatures. And the other thing that is also distinctive is switching. Right now, you speak French. don't you?
I do speak French, yes, a little at least. I mean, je me débrouille.
Bon, alors je pourrais ici essayer de parler un peu en français. And what I just did was, and then I came back to English, right? So that capacity to switch between languages across utterances is another thing that's very peculiar about the bilingual mind, if you will. And because we use language so much in our daily lives, like here's a cool mental experiment for you. Try to think of a moment in your day in which you're not using language.
Difficult.
It's hard.
Difficult.
Very hard, right? Because maybe, I mean, just think about, I mean, you're at any point in your day, you are talking or listening to someone, reading or writing, or listening to your inner speech. And if you think about, well, how about when I'm alone? Well, you're heavily using language when you're alone, and you may think about sleep. Well, there's a lot of linguistic processing during your sleep as well. So it's hard to think about moments in which you're not using language. When you're a bilingual or a multilingual, and language is taking up so much time of your life, it means that all these mechanisms that are switching off one language as you're using the other, that are keeping control of both languages when you're switching between them or we're trying to minimize the mixing between them, they are continually taxed. You're placing lots of demands of them. And just like when there's a hypothesis that claims that just like when you go to the gym and you tax your arm, you know, by lifting weights, you tax it and the muscle gets bigger. Well, continual taxation of these mechanisms ends up making them more robust, more efficient. There's abundant evidence that continued use of two languages may be beneficial for the development of certain cognitive capacities, especially in certain executive domains. And of course, there's also evidence that speaks to the contrary. But what we've been learning so far is it's not a matter of whether, yes, you found an effect and it's true, or, oh, you found a null effect and that's true. It's more of a matter of understanding under which conditions and under which specific types of configuration of a bilingual mind the continued use of two languages brings about these effects or not. But to sum it up, the bilingual mind is quite peculiar, and it differs from the monolingual mind in a number of respects. And one final thing to say is that the bilingual mind is not the exception to minds in the universe. On the contrary, well over half the world's population regularly uses two or more languages. So that by studying bilingual minds and their intersections, we're not really looking at a footnote in the textbook of linguistics. We're actually looking at what typifies language use for the vast majority of people in the world.
So when you say it's kind of a muscle that you're training, right? So when I use my languages a lot, in a way, I'm getting better languages because the language muscle is trained. But then also at the same time, there are a lot of people who are already multilingual. What's about the other way around? Is our brain maybe also just wired for languages and maybe also even for multilingualism?
There's no evidence that I'm aware of that suggests that specific brains may be better wired for bilingualism than others, if that's the point. But there's definitely our human brain, our brain is very much adaptive in nature. It's one of its core properties, if you will. It's a highly predictive organ. It's a highly associative organ. It's a highly vulnerable organ, but it's also a highly adaptive and plastic organ. So what this means is that what your brain endows you with when you're born will in a way shape many of the things that you do, that you can do and that you cannot do. So for instance, you wouldn't be able now to calculate in the spur of a second, 10,045 times 2,052,000, right? Okay, so there are things that we're just not ready to do very easily. But And just like our brain shapes what we are able to do and not do, what we do shapes our brain back. And that loop is very much, I would say, overlooked sometimes when there are unidirectional views of either this direction of the influence or this direction of the influence. And one of the things that we do is we use language, and we use it in a certain way, and that ends up sculpting your brain in a particular way. So there's this back and forth, this give and take between your biological endowment and what you do with it, but also what you do and the sort of pressures and processes and events that you expose your brain to, and how they exert an influence on what your brain has to do to make them feasible.
Kind of a positive feedback loop, a system that reinforces itself, which
It is.
probably is quite strong, especially, I mean, if you think about translation, interpreting, where you're always kind of juggling between two languages. I suppose it's probably strongest, I mean, strongest relationship over there. I mean, the strongest feedback loop probably you can get if you're working these kind of language professions. Is that true?
It is true. It is true. Insofar as we can believe the evidence out there, but just like I was pointing out some differences between multilinguals and monolinguals, so there is a line of work which compares people who have sustained experience in specific interlingual reformulation modalities, simultaneous interpreting in particular, that's where the bulk of the evidence comes from, and non-interpreter multilinguals. And when you have those comparisons, there's quite consistent evidence that those who undergo systematic practice of interpreting, they do seem to outperform non-interpreter multilinguals in a number of cognitive domains. The most consistent evidence has to do with working memory, but there's also some evidence about processing speed in general and the ability to handle simultaneously conflicting tasks. So yeah, absolutely, there's something to be said about the impact that sustained practice of specific interlingual reformulation modalities can have. And this is not just something that you observe behaviorally. When you compare the brain, the structure, let's say the gray matter density of interpreters versus non-interpreters, or the integrity of white matter tracts, or patterns of electrophysiological modulations, both at rest and during specific tasks, linguistic and non-linguistic, there's converging evidence that at the very least suggests that there's something special about the way in which the interpreter brain is configured relative to those who are equally multilingual but not exposed to simultaneous interpreting in their daily life.
It's absolutely fascinating research. Do you feel that kind of your practice as a translator, English teachers, kind of helped you to do this kind of research, or?
There's something about so some of the research questions, they come from experience and intuitions that you have when you're using your languages, when you're teaching them too. When you think about why is it that students, find this easier to process? Why do they always sort of struggle with this type of construction? Why is it that sometimes they find it easier to learn A when they were previously taught about B, for instance, right? So the questions sometimes are informed by praxis, if you will. There's also a little bit of introspection of your own internal theories of how what you're doing may be actually happening in your mind. And those introspections, I mean, we tend to ascribe much certainty to them. We tend to believe ourselves too much about the personal hypotheses and theories that we come up with to explain our world and our inner world in particular. But then at that point,
yeah.
we can be so biased. We can be so. That's precisely it. Because sometimes you can go ahead and just accept that bias, and you go through life with that, and it's perfectly okay. But at some point, when something that science teaches you, that you learn from science, is that nothing is ever certain, and that your own intuitions about yourself are particularly prone to deception and biases and distortions and desirability tendencies. So that's also been a source, and it remains being a source of questions that then inform the designs, the methodological designs that you use, the stimulus selection. So yeah, there's a little bit of a back and forth between science and practice there too.
So that now begs the question, is there some of your intuition or hunches that you had that were rejected by the studies or by the research that you conducted? Maybe
Yes,
some also
yes.
were confirmed, I assume.
Some of them were confirmed. Some of them they remain at a point of indeterminacy, if you will, and some of them were completely falsified. Let me give you just one quick example. With this study, in which we were using non-invasive brain stimulation with transcranial direct current stimulation over the left primary motor cortex of healthy individuals, and our prediction, we were using a nodal stimulation, which usually tends to upregulate, let's say, to hyperactivate the tissue that you can actually reach with that. So we were asking ourselves whether that pattern of stimulation of the motor cortex would influence the way in which people understand motor actions in texts, in naturalistic texts. Our hypothesis was that if we upregulate the motor cortex, then people are going to understand action concepts better than they understand other non-action categories. And that was our hypothesis, and it was completely wrong. It was the results that we found, they were they did not confirm the hypothesis, they were diametrically opposite, because what we found is that if you do that, you actually selectively reduce outcomes, performance on comprehension of action concepts. And then we reasoned, okay, so maybe what's happening is that because you are raising these circuits to such a high level of activity, and then you're demanding something else from them, which is to participate in the understanding of these concepts, because the line is busy, right? They are not readily available to contribute to this other function. But we needed the evidence to come up to arrive to this conclusion, which was then corroborated in other studies by other labs. But what we started off with was completely wrong, and that also taught us something. Hypotheses, they are fundamental in science. You need them. They are you need them to guide what you're doing. You don't want to just be fishing around, but one must not overestimate hypotheses, because hypotheses come from sources that are limited. First, what the world of science and the world in general has learned about a certain phenomenon so as to guide your predictions, and then your even more restricted knowledge of what is known. What is known about the world is limited, and what you know about what's known about the world is more limited, and that's the foundation for your hypotheses. It could be through inference, through association, by reading someone else's work. It could be a hunch, whatever it is, but it always sort of sub-represents the extent of knowledge that there is, and you have your biases as well. So sometimes something that I learned in this process was, yes, hypotheses are good, but don't marry them just too soon. They can guide you, but you don't want them to dictate where things have to go, should go, or what you should do.
And unexpected results are probably the most interesting ones also, because they make you think really hard about the data you have, right?
And also because they challenge this tendency that we have to, there are a couple of biases we're talking about them, which is the confirmation bias, which is to try to unconsciously try to accommodate the evidence to your existing worldviews in a way. And there's another one, which is apophenia, which is the tendency to find to think that you find patterns in noise. And when you combine these two things, you are in a complicated position where you can actually fall prey to coming up with self-indulgent interpretations. When the data are so diametrically opposed to your hypothesis that this isn't even possible because you can't even find your way to accommodate the conflicting data with your pre-existing thoughts, it's very good because it does force you to challenge what you were thinking ahead.
Absolutely. And now recently you have dived into another area of research, not totally different, a little bit related, but then still different enough, which is dementia, right? And you're conducting right now a large project on how to use language patterns in dementia to predict and diagnose dementia. Is that right?
Yeah, we've been working on this for a number of years now. And we've been working mainly on neurodegenerative disorders. Most of our work we've done on Parkinson's disease. And starting a few years ago, we started moving more focally onto dementia, mainly Alzheimer's, amnestic type dementia, and different variants of frontotemporal dementia. And the idea basically goes as follows. Something that you learn in neurolinguistics is that there are different parts, portions, networks, and mechanisms in your brain which are differentially implicated in different linguistic processes. So the contribution of the primary motor cortex is not the same when you are comprehending or producing action verbs, things like run, jump, applaud, that involve bodily movement, as they are when you are processing abstract verbs, things like think, imagine, desire, right? In which there's no bodily motion involved. When you're engaging in syntactic processing, certain mechanisms are engaged at a differential level. When you are processing phonological information, the same is true, and so on and so forth. So when you learn about these connections, that certain aspects of language map differentially into specific brain circuits and networks, you can sort of flip the equation and say, okay, now, if this is true, then maybe I can use those linguistic elements as a telescope, as a window into the integrity of those brain mechanisms. And that's the entire rationale of what we are doing. Why is this relevant? Because these neurodegenerative disorders, their atrophy epicenters and their main patterns of hypoconnectivity or hyperconnectivity from in very early stages and even preclinically, they engage areas that participate in some of these linguistic processes. So in Parkinson's, the basal ganglia, they play fundamental roles in phonetic and phonological processing, for instance. And that's one of the very, very, very first areas that becomes atrophied in Parkinson's disease. So if you take a look at measures of phonetics, it could be speech timing, voice quality, it could be speech timing, prosody. You can find markers of whether those circuits are working well or not. And the latest thing that we are doing is, because at the beginning we worked with classical approaches in which we used either linguistic batteries, paper and pencil tests, in which you can measure how well people do in this or this task. And then we moved on to more psycholinguistic experiments with computers and measuring response times and accuracy measures and things like that. But the latest thing that we've done, and our first paper in this line was published in 2016, is to use artificial intelligence. And basically now what we can do is to use algorithms that can capture objective markers of your phonological, phonetic, syntactic, morphological, semantic choices and processes. And this is very, very good because there's a lot of inequity around dementia neurodegeneration. Standard diagnostic procedures, they are quite costly. They are not evenly available across world regions. The time from complaint to consultation can be weeks or months. So if you can come up with automated solutions that are time efficient, cost efficient, that can be administered autonomously using just a phone when you record yourself, then you can do something to hopefully better the chances of people who are underserved, but paradoxically at increased risk for these disorders.
So just to get this right. So basically what you're doing is kind of you have an app on your phone, you speak in your phone, and then the app tells you, please go see a doctor. Oh, no, you're fine. Is that
the way in which we capture data, you can do it through the phone, or you can go to a clinic or a hospital and you are recorded there. And what the app does, and we created an app to do this. Actually, we set up a company which is called Tell, and what the app does is it captures the audio file, it pre-processes it, and then the audio file, it extracts features. It calculates speech timing, prosody, things like that. Then we automatically transcribe the audio file and we run NLP algorithms, natural language processing algorithms, on the text. And you can see what are the lexical, syntactic patterns and so on. And with that information, basically you have a couple of things. You can see whether your values, whether they fall within the range of a healthy individual or someone with a certain neurodegenerative disorder. Or you can feed that information into machine learning classifiers, which can give you the probability with which your speech and language features coincide with the speech and language profile of a healthy individual or someone with Alzheimer's or Parkinson's. This is not the same as providing a diagnosis. These tools, they cannot give you a diagnosis, but just like when you do a blood test, you do a blood test, and the blood test that will not tell you you have this disease. It's just values that can help a clinician reach a better and more informed decision.
It's a little bit like a screening also, right?
It contributes to screening purposes. It can support differential diagnosis. This approach is also useful for phenotyping, that is to say, to discriminate among different variants of a given disease. It's useful for monitoring, for predicting the severity of core symptoms, to predict the levels and the patterns of brain atrophy and hyperconnectivity, and also to assess response to treatment, because that's another thing that you want to have indications for, and for which automated speech and language analysis can be of help.
That's absolutely fascinating. And also, I mean, of big relevance, of course, for society, right? If you think of the costs and the burden that these diseases put actually on the healthcare system.
And you're touching on a critical point there, absolutely, because this whole thing was sort of an exercise in dissatisfaction. So after you work for a while on finding markers of these diseases, usually what you do is you write up a paragraph in the discussion section, sort of speculating, imagining how that could be useful in a clinical setting. But there's always this feeling that, okay, but how do we make that happen? It's absolutely critical to produce the evidence. Absolutely. We need the basic research, and it's fundamental. But then you're always like hoping that someone will come and sort of implement that. And then how will they do it? When will they do it? Which reasons will they do it for? So at some point you say, okay, why don't I give it a shot, right? And it's a way to try humbly from our area of expertise to contribute to a pressing, very multidimensional problem in society.
To be the visionary, but also at some point to set the vision also in action. And this is somehow what you seem to be doing quite a lot, actually. I kind of just had a brief look at your CV, and I counted something like 20 publications preparation, around 20 projects that you're leading right now, a few positions and additional occupations. You seem to be juggling with something like 3,000 balls at the same time. How do you actually manage that? And have you ever dropped a ball?
It's well, the first thing is that all these things, they are team efforts, all of them, absolutely all of them. And these teams, I have the fortune to work with people who are absolutely phenomenal at what they do, including the clinicians, people who manage data, colleagues, mentors who have taught me a lot and still cope with me and keep working with me. Students who are brilliant and who come from many different fields, such as engineering, data science, audio engineering, psychology, things like that. So that's the first thing. Because those balls that are being juggled, you're not really juggling the entire ball, right? Or you're juggling a part of the ball, if you will. And that's the main thing. And the other thing is, something that I've learned is that there are things that I'm good at and things that I'm not good at. And for a long time, I thought that the way to progress was to start becoming good at the things that I was not good at. And but there's another way to think about progress. I mean, that makes sense. But the other one is, okay, if I'm good at this, why don't I try to maximize that in which I'm good at? And I'll let those spaces in which I'm not good at be handled by people who are experts in that. So all of a sudden you maximize the effort to contribution ratio in a way. So because you're always leaning on your strengths and leaning on someone else's strengths to cover up for your weaknesses. So I think that's the main thing that I don't think it has anything special. I mean, all of us handle many balls at once, and but I think that a good point for scalability is this, to acknowledge what you're good at, what you're not, and how you can actually improve the project by not trying to do everything yourself.
That's a wonderful answer. And now I need to ask you a last question, because this is our anniversary episode, to see how did you get the idea for this podcast?
So something that I think is important in science is for it not to be endogamic. So if you do science and the only audience, the only recipients of your science are other scientists, that's good, but maybe we're not really communicating what we are doing in its maximal potential scope. So for many years with our groups, we've been engaged in public dissemination of science, of what we do, be it through massive live events or documentaries or media actions of different types. When I took on the presidency of TRAC, of the Translation, Research, Empiricism, and Cognition Network, which I had the honor to sit at for 4 years, we made it with the management team. We made it one of our goals for that period to try to contribute to the visibility of our field, to what we do, to break a little bit the boundaries, the disciplinary boundaries between the different specialties that exist within cognitive translation and interpreting studies, but also to reach out to people who, by jurisdictional boundaries, may feel outside of this discipline, but who still have an interest in multilingualism, language teaching, language processing in general, and even beyond that, people in general who have an interest in science and in understanding translation and interpreting, because everybody is faced with that. You turn on, I don't know, Netflix, right? And you're watching the subtitles of this series that you love. Well, you are a participant in the sphere of translation and interpreting. So that was the motivation. And then the rest was very simple, because we have such a tight, diverse community of brilliant scholars with such varied trajectories and interests and methods and geographical and cultural flavors, if you will, that that it was quite easy to make it happen. You just write to someone, you read a little bit about what they do, you come up with a few questions, and you just let them fly, and it just works wonderfully.
Exactly. And you flew high. Thanks a lot for this interview. And happy birthday. Minds Between Languages. Been a wonderful interview. Thank you so much.
Thank you so much, Anne-Catherine. And let me say that I couldn't think of better people for Minds Between Languages to be in the hands of than yourself and Natasha. Pavlovich. It's been fantastic to see you take this show to the next level and to do it with such a level of professionalism and this breeziness of style that is just, I think, what we need. So kudos and thank you very much for what you're doing.
Yeah, thank you so much. That was so sweet.